First of all, I'll show the first order response. Okay, so first you need to specify the time that you are interested in. For example, I specified the time between 0 to 2, and the time interval between those two values is about 0.01. So you'll have 0, 0.01, 0.02, and so on and so forth until the time reach 2. To define the transfer function, first, for example, you have this. I define the plan as G1, and to make a transfer function, you type G1 equals to TF, stand for transfer function, and you find the zeros. In this case, we only have 3, a plain gain, and you have 1, 3. So let's see what happens when we run. So the transfer function for G1 is equals to 3 over S plus 3. You can also define for G2 7 over S plus 7, and for G3 we have 14 over S plus 14. So you can plot individually using the step function, for example, for let's say G1. So we have G1, step G1, this is the response, the step response of the system G1. Okay, in this example, you already given the closed loop transfer function as in this figure. So you can just use the step function to find the step response. So again, this is the step response for G1. So in case you want to plot all the response in one figure, so we just run this function. Oh, sorry. Okay, you have to specify the t, and you run the function. Yep, and you have all 3 functions here, and you can label or put the legend and set some what we call it, the limit for x and y. So we run this function, and what happened is that it plots from 0 to 1.2 on the y-axis, and for the x-axis you have time from 0 to 2 seconds as specified by the t that you have declared before. And you can find the info, for example, for the system G1 by using the step info function. You find that the rise time, the settling time, overshoot no, underpeak no, a peak and peak time. And you also can find by right click on the plot and set the characteristic, either peak, settling, peak response, settling time, rise time, steady state. For example, we select the peak response here for all 3 of the systems. How about the rise time? Yep, it's different from system to system, and you can see by clicking on the dot on the plot. The same goes for system 2 and system 3. You can run the step info, and also you can right click on the plot. Next, we try to find the closed loop transfer function of the second order system. Let's say this time around we set time from 0 to 15 seconds, and you have the transfer, you have a plan G4. So the G4 is defined as 3 over s squared plus 3.6s plus 6. So you can find the closed loop transfer function, for example here G2 or G4. So you have 3 over s squared plus 3.6s plus 6, and this is the respective diagram for the closed loop system. And you can find the closed loop transfer function by using g over 1 plus gh. So the closed loop is 3 over s squared plus 3.6s plus 9. So for the MATLAB, you can use the function feedback. So you have feedback of G4. 1 here means the feedback, unity feedback 1. So let's see. Yep, the closed loop transfer function is 3 over s squared plus 3.6s plus 9. Similar as what you find by calculation. And from this point, you can find the output response for different type of input. For example, impulse, step, or ramp.